Okay, we're going to finish up. We're going to do three pretty short videos. So if you pick up on your notes on section 8.1a at the bottom of page 2, it says, is it a polynomial or not? Now, we talked about polynomials in the lesson before this. And to see if it's a polynomial, a couple things that have to be, here's what makes it not be a polynomial. A polynomial can be something like 5x, but one of the rules, the exponents have to be whole numbers. If you look back at the definition that we gave yesterday, they have to be whole numbers. So even though I don't see a number there, I do know that the exponent on the x, and now only on the x, the exponents have to be whole numbers. So up in the air. So if I have x, y squared, all the exponents are whole numbers because the x has a 1 on it, the y has a 2 on it. That would be degree 3 because when they're being multiplied like that, you add them up. The other thing, how are they not whole numbers? You could have something like this, x to the 1/2. That is not a polynomial because the power is a fraction. Okay? So if you see the power, it would be a fraction. Now that is also written as this, the square root of x. That's what x to the 1/2 is. So, thank you. So that would not be a polynomial. Anytime you see a square root, so you can make a little note right before we do these. If I see a square root of a variable, or I see it to a power that is to the 1/2, or there's one more rule. If it's to the negative, remember what the negative does, it moves it to the bottom. You can have no variables in the denominator. So then we're just going to go through these examples and decide, are they polynomials? This one, it doesn't matter if they're being added. This one, the x is to the 3rd power, and the 13x, the x is to the 1st. So underneath this one, you can put, yes, that's a polynomial, or next to it somewhere. Now the next one is kind of a trick question. Right away, you might say, I thought you said there were no fractions. No fractions for the exponents. This isn't an exponent. This is a number. This one is a polynomial because all that is the number 2/3 or 0.6. That's fine because there aren't any x's. If there was an x, the x would be to the 0 power because anything to the 0 is 1. That's why we don't see it. So therefore, that one's fine. But the next one has a negative exponent. So that one is therefore not a polynomial. As soon as you see the x to a negative power, it would move the x to the bottom. X can't be in the bottom. This one is 2 over x, so that one is not a polynomial because it violates one of the rules. So now if you would quickly look at these 4, I want to give you just 20 seconds to look at the 4. You should be able to look and see if there's something wrong. You say it's not. You can just say not, and the other ones you can put a P by it. So it's not a polynomial or it is a polynomial, and that's enough. So this one, polynomial. The x is to the 1st power, the negative 3. If that threw you off, I thought you said no negatives. Numbers can be negatives, exponents can. The exponent is a 1, it's fine. This one, no square roots, so that one's not. How about this one, yes or no? Is it polynomial or not? Yes. How about that one? Polynomial. Again, it's only the x. If the x has the 1/2, if that threw you off, that's just a number. It's a number 0.5. We can have that. Okay, next. It says we're going to classify it on its number of terms. Okay, and then we're going to classify it on its degree. So in this second section, I think here, we're in exercise 2. It says in the directions, you don't have a table like this, but read the directions. It says classify each polynomial on its number of terms and state its degree. How many terms does this have? 1. We call that a what nomial? Monomial. Okay? What's the degree? What's the exponent? So that's a first degree. Okay? Hopefully that's coming back to you from yesterday. How many terms here do you see? We call it a what nomial? Okay? How many terms here do you see? 4. Anything over 3, we just say, what was the term yesterday? Polynomial. This one is a what's this one? Monomial. Okay. Now the degree, there are 3 terms over here. What's the highest degree? 5. What's the degree on this one then? And the degree on that one? Careful. Okay, very good. All right. Any questions there? Can I move on? Write the polynomial in standard form. Now, if you've forgotten what standard form, we find the one with the highest power, in this case, the 3x squared, and we write it in descending powers. So the x squared, the 2, puts that one in front. Next, we put the negative 7x, because that would be to the first power. We don't want to put it there, but it goes down 1, and then plus 4, because that would be an x to the 0. So it goes 2, 1, 0 in terms of the powers of x. That's now in what we call standard form. But then name it based on its degree. So this one, the degree is what? Degree of what? 2, because that's the highest power. And then how many terms? What do we call it? Trinomial. Okay, so we take the next one. I'm going to give us 20 seconds for each of these. So we got about 40 seconds. Those watching the video at home, you got about 40 seconds. If you get it done faster, you can always fast forward. Got 10 more seconds. Highest power. Makes it degree 3 because the number up in the air is the degree. That's the highest power, so it's degree 3. Then we come down 1, 4x squared. Then we come down another 10x. Then we come down another minus 2. How many terms? Terms, so we call it a polynomial. Poly means many, many terms. All right, the next one. Highest power is to the 7th. So that is degree of 7. There are 4 terms. So this one is going to be a polynomial. But we go negative 4x to the 7. Oh, no. Changed my mind. I just caught something different here. This one is a trick question a little bit. We've got 2 of them that are to the 7th power, right? So we're going to take those 2 and we're going to combine them and make it negative 7x7 and combine those 2. And then these 2 are also the same. So if we combine those, 3 minus 2 becomes 1. So now it changes that one. If we correctly combine all the terms that are the same, we get a binomial. Now you might say, why can't we put those together? You can only combine the ones that are alike in terms of their power. They have to be exactly the same. Everybody good here? Next up. We're going to learn in section part B how to combine the like terms. So that last one was a little bit of a preview of this short lesson that we're going to do. And we are going to do both lessons B and C on here today. Okay, so to add like terms, the trick is you want to add or subtract things that are alike. Okay? If you have 3 bears and somebody gives you 2 more bears, it's pretty simple. How many bears do you have in your zoo? 5 bears, right? Okay? Because they're like animals. They're animals of the same kind. All right? But if I have 1 bear and 4 cats, and I add 6 bears, 2 cats, and 3 dogs, what I can do is I can take my 1 bear and add it to my 6 bears and have 7 bears. I can take my 4 cats, add them to my 2 cats, and I have 6 cats. I can take my 3 dogs and I still just have 3 dogs. There were no like animals of the same kind. What I can't do is add these. I then have 7 bears, 6 cats, and 3, I don't know why this stupid looking dogs is on there, but we do know that cats are better than dogs because cats or dogs cannot operate an MRI scanner, but cats can. You'll get it later. Cats can operate because it's a CAT scan. Never mind. All right. So if you like dogs, whatever, it's good. So I didn't mean to, I don't know, I actually didn't make that slide. I just take the stupid looking dogs out. Sorry about that. But what we don't do is we don't take 7 plus 6 plus 3 and say it's 16 bear-cat dogs. Because we can't put them together, right? So we can only combine the ones that are the same. Now that's the same thing is true here. So when we're looking at this first example, what you want to identify is ones that are the same. And the way they're the same, look at their exponents. So here we have 2x squared, and we are going to add 1x squared. So 2x squared and 1x squared, when you add them, it's like having 2 dogs and 1 more dog. You now have 3 dogs. But a mistake a lot of students make is they think it changes the power. The power is still an x squared because the cat is still a cat. Okay? So you went 2 cats plus 1 cat, you now have 3 cats. Am I making sense? All right, now we look at the next one, and there's one here, there's a 1x, and here there's a 1x. Well, we have one dog and one dog, so we have 2 dogs, but the power didn't change. We just added the numbers. Okay, everybody doing this one on there? Okay, now the next one, we have -5 and +6. Well, 6 minus 5 is 1. But those are like terms. But we combine all the different like terms, and then we get an answer. Now, hopefully you see why I did the cat-dog example, right? Because it kind of makes sense when we put it into something that, well, yeah, of course I wouldn't say 2 bears and 2 cats make 4 bear cats. Okay? Doesn't make sense. Right? If you have 2 bears and 2 cats in the zoo, you have 2 bears and 2 cats. That's what you have. You have 4 animals, sure. All right. So now we look at this next one. What you have to do, it's a long one, and it's like, why is that so long? Let's start by finding the highest power. The highest power, I believe, has a 3 on it, and there are a couple that have a 3. So we have 2 minus 1. 2 minus 1 makes 1. So there's 1x to the 3rd. We don't put the 1 in front. That's common practice. Now we look for the next thing. If this is a 3rd power, let's come down 1 power and find all the ones that have 2's on them, and there are several. And we're going to put those together. We have a +2, a +3, and a +4. 2 plus 3 plus 4 is 9. And those are x squareds. The power doesn't change. You don't all of a sudden get x to the 4 or x to the 6. Now we got -x, -4x. That's minus how many x? -1, -4 more. Negative what? 5x. Good. And then lastly, we have 7 minus 8, which is, careful, -1, because the negative is bigger. Oh, there's a +7. My fault. I missed that. So a +7, so 6, right? 7 plus 7 is 14, minus 8 is 6. However you want to do it. Pretty good? Sorry, I missed that +7. For those watching the video, the answer was not -1. All right. Was that it? I thought I eliminated these other slides. These aren't supposed to be in here. I got to get rid of those. Well, I don't know what happened to the other one, so I'll add these in. Put this down. 2x to the 4. Wait. No, it's 11 m squared, right? No, I didn't write these down. On the next one. 11 m squared minus 3. Now, I want to address something that I haven't addressed so far. When you start and you look at this, why are the parentheses there? The parentheses are there because you're taking one term that has 2 terms and adding it to the other one. So one of the things you do have to recognize that we'll see in the next part of this lesson is what's in between. Since it's positive, if I remove all this stuff, it's like there's a 1 out in front of here. And a 1 times all this wouldn't change anything. Out here, there's a 1, and that wouldn't change anything. So when you see a positive in between, you can remove the parentheses and nothing will change. In the next part of this lesson, you're going to see that a negative is going to have an impact on those things. But now we take these and we combine the like terms. 11m squared plus 8m squared is 19m squared. Again, 11 dogs plus 8 dogs makes 19 dogs. Then 3 minus 4 or 4 minus 3 is a positive 1. D. Two p to the third plus 6p squared plus 10p. I have removed the parentheses because there's nothing in front, so the number isn't going to change. Then I'm going to remove the next parenthesis, 9p squared plus 11p minus 3. And now I look for like terms. 2p to the third is the only one of its kind. 6p squared, 9p squared, 15p squared. 10p, 11p, this is the only one of its kind, minus 3. Is that making sense? Okay. One more little section. Oops. Everybody got it? Now, in this section, we're going to see a negative in between. If you look at section 8.1c, there's going to be a negative. So to subtract, you add its opposite. Now, in other words, we're going to multiply some things by -1. So in this one, what you'll notice in between here, in those past 4 problems, look at them again, there was always a plus sign in between. The ones we're going to do now all have a minus sign or a subtraction sign. So first, before you do this type of problem, you have to make this a practice. I'm going to remove the parentheses here and nothing changes. It's x squared minus 8 because there is no negative in front of that one. So that one won't change when I remove the parentheses. But this one, there is a negative. So it's -1 times 7. Now in here, the 7 itself is positive inside. So when I remove the parentheses, it becomes a minus 7x now. It wasn't a minus before. Just look inside. Forget about the outside. Inside, it's positive. So now it became negative. Now inside this one's positive. So now it becomes negative. So that negative changed both things or all the things inside. So now this is 1x squared minus 4x squared. That gets us -3x squared. Again, you have 1 dog, subtract 4 dogs, you have -3 dogs. Then, minus 7x minus 8. There are no other terms that are alike in terms of their x's and the powers. So this becomes a 3-term or a trinomial in the end. Ready for part B? Almost there. So first thing we want to do is we want to remove the parentheses. -2x to the third plus 5x squared minus x plus 8. In removing the parentheses, this is a -1, and we multiply, we get plus 2x to the third minus 3x plus 4. So notice all my numbers that I wrote in blue, I did that on purpose so you would see, inside they were the opposite. The negative changed all 3 of them. Did I do it correctly? Everybody agree with me? All right. So now we look for the highest power in the like terms. It just so happens -2 plus 2 becomes 0x to the 3. Now don't write this, but 0x3, 0 times anything is 0, so we wouldn't write it. The x3 is gone because those two are exactly opposite of each other and they cancel out then. Now we go to the x squared and we have 5x squared. Minus x minus 3x is minus 4x. And there's only a plus 8 left. So I go plus 8. Oh, there's a plus 4. I did it again. plus 4. Good catch. Thank you. So we put those together, and it should be plus 12. Thank you for correcting me. Thank you. All right. Whoop, back up. Are we good? Okay. All right, so now this one's part C, I believe. Remember, when you see the negative, you have to show a little work to help yourself out. This one, taking off the parentheses does not affect the first part of the problem. But taking off the parentheses here makes that one negative, makes this one positive, and makes this one negative. The negative, what do we call that process? That's the what process? Where you multiply by each thing in there. Starts with a D. Distributive. Good. Nice job. High five across the room. All right. So, now we put together our like terms. We have a 2x to the 4. We have a 5x to the 3. We have an 8x. Whoa, I missed one. 5x to the 3 and a negative x to the 3. So these, 5 minus 1 is 4x to the 3. Then we have an 8x squared. Then a minus 3x. And a minus 11. We end up with 5 different terms when we're done. Polynomial, many terms on it. Or a 5-term nomial. Last one on the video. A little longer video today, but hopefully been pretty good. Everybody understanding pretty well? Okay, now here's a little bit of a difference. We've got multiple variables. We got some A's, we got some B's. Okay, so first, let's just take all the parentheses off. So the same thing is true. The negative goes through all these, so we have a negative, yellow's too light. For A3B, a positive AB squared, and a positive 5AB. It changed all 3 signs. Okay, now where we start, typically, math has order, so we want to use the order. So we usually start with the highest power of the alphabet that comes alphabetically. So I'm going to look at the A's first. So here, I see an A to the 3rd power, but it also has a B on it. So any term I add has to be the same thing. This one has an A to the 3rd with a single B. Those two are like terms. So I have 1 here and I have negative 4 here. So what I have is negative 3A3B. Again, it doesn't change the exponents. It changes the number in front. Okay, now, the next one, I could go either way on this one, but typically if there's 2 variables, you then just focus in on the one where they have some things the same, and then in the second variable, the highest power goes last. Okay? So here, I have 1 with an AB squared. The B squared is a higher power because this one was B to the 1, right? So you put the second variable later then, if you have 2 variables like that. And then I have 1 AB squared. Those 2 are like terms, so I have 1 and 1 make 2 AB squareds.